This is MSJ Chem. In this video, I'll be looking at the choice of solvent for SN1 and SN2 reactions. We'll start by looking at the difference between polar protic and polar aprotic solvents. Polar protic solvents contain oxygen to hydrogen or nitrogen to hydrogen bonds and are able to form hydrogen bonds. So here we have some examples. We have ethanol on the left, ammonia in the middle, and water on the right. Each of these molecules contains either oxygen to hydrogen or nitrogen to hydrogen bonds. Therefore, each molecule is able to participate in hydrogen bonding. Polar aprotic solvents do not contain oxygen to hydrogen or nitrogen to hydrogen bonds and are unable to form hydrogen bonds. Here we have some examples of polar aprotic solvents. On the left we have propanone, in the middle we have ethane nitrile, and on the right we have NN-dimethylformamide. These molecules do not contain oxygen to hydrogen or nitrogen to hydrogen bonds and are therefore unable to participate in hydrogen bonding. SN1 reactions are favored by the use of polar protic solvents. This is because the solvent molecules solvate the carbocation intermediate through ion-dipole interactions. Here we can see a carbocation surrounded by a cage of water molecules. The ion-dipole interactions occur between the negative dipole on the oxygen atom and the positive carbocation. This has the effect of stabilizing the carbocation intermediate produced in the SN1 reaction. The solvent also stabilizes the anion, which is the leaving group, by forming hydrogen bonds, which also favors SN1 reactions. So here we have a leaving group, which in this case is the chloride ion, surrounded by water molecules. The hydrogen bond occurs between the positive dipole on the hydrogen atom and the lone pairs of electrons on the chloride ion. SN2 reactions are favored by the use of polar aprotic solvents. Polar protic solvents solvate the nucleophile due to hydrogen bonding, reducing its reactivity. So here we can see a nucleophile surrounded by water molecules. The hydrogen bonding occurs between the water molecule and the nucleophile, which reduces its effectiveness as a nucleophile. Polar aprotic solvents do not solvate the nucleophile as they are unable to form hydrogen bonds, maintaining its reactivity. This favors the SN2 reaction.